Welcome you all to the last day of the Python with Magicbit program. Today our activity is clock time. Just like the previous sessions, today also we are going to use the MicroPython language with the Magicbit device. So first of all, your Magicbit should connect it to the Magicbit web uploader. The link to the web uploader is given in the description box below. And from that, you have to install the MicroPython firmware to the Magicbit. And then you have to open the Tony IDE, which is installed in your computers. And then you have to connect the Magicbit with the Tony IDE to get the final output of the program through the Magicbit. And now when you open the Tony IDE, installing the MicroPython firmware into the Magicbit, though you connected it with the USB cable in the Tony IDE, the console will having this red color text. So what you have to do, go to the Run menu in the menu bar, click on the Configure Interpreter, and there this should be MicroPython ESP32, the first selecting option, and the second one should be you have to select the available serial port, or you can use the second option. And once you click on OK, you will see this red color text will disappear, and this the green color Run button, which is next to the save icon, will appear to select. Like this. So what we are going to do today is, as I told you in the first slide also, it is clock time. So when you hear the word clock, you will get to know what is we are going to do. It is some kind of a clock. So the clock is actually a digital clock. So we are going to program our Magicbit to print or display the real-time digital clock with the hours, minutes, and second format. That means the number of hours, number of minutes, and number of seconds at the time, which is equal to the real time, will display on the Magicbit display in 24 hours format with this hours, minutes, second format again, right? So we are going to display it on the Magicbit OLED display. We can make it to print in the console of the Tony ID as well. But as we are using the Magicbit, as we are having a display here, we can do that on the display. So this is the OLED display. You know this because we have used it in our first activity as well. So a digital clock, which is displays the time digitally. That means in numbers or in other symbols. That means, as I told you, 24 hours format. That means afternoon times, that means 1 p after 12 p.m. or 12 noon. We don't call it as 1, 2, 3 like that. We call it as by adding 12 to that number. If it is 1 p.m., we are not going to display like 1 p.m. We are going to display it like 12 plus 1. That means 13 as the number of hours. And the minutes and seconds are they are same. But the number of hours will be changed in the 24-hour format in the afternoons. So in our activity, first we need to import the necessary libraries and necessary classes in that libraries. So these are the three libraries we are going to use. The machine library. In the machine library, we are importing the pin class, PWM class, and the I2C class. And from the time library, we are importing sleep and the local time classes. And then as we are using the display, we use the SSD 1306 library. Okay, let's go to the Tony and import these libraries and classes. So first we need to, from the machine library, we need to import, sorry, there is no the, from machine we need to import pin class, PWM class, and I2C class. Then from the time library, we need to import the sleep class and local time. Yeah, it should be simple, local time. And then we need to import the SSD 1306 library for the display. So after importing the OLED display, after importing the necessary libraries, we need to initialize our OLED display. That means the pins that are relevant to the display and width and the height and those information according to the library we used. So we are defining a component called I2C, and that should be equal to the I2C class, and within that -1, and then we need to define SCAL, SDA pins. So SCL pin is in pin number 22 of the Magicbit and SDA pin is in pin number 21. And then we need to define the width and the height of the display. OLED width is equal to 128. OLED height, that is equal to 64. And then we need to define all these three things according to the library we use, SSD 1306. So we'll define it as OLED, and then from SSD 1306 library, the class is SSD 1306 in capital. And then what we need to do, here there should be an I2C part as well. So it should be in capital. Three terms we used in earlier 3 lines. OLED width, OLED height, and I2C. Right. So that is how we initialize the OLED display. So after initializing the OLED display, then we have to initialize the buzzer. Why we need the buzzer? Here in this clock time, when it passes 1 minute, we are making a small buzzer output from the buzzer in the Magicbit. Just like making alarms, each and after passing each and every 1 minute. You can edit this to happen after passing every 1 hour, every 30 minutes, every 10 minutes, like that. That is up to you. But as I need to show you the output at the within this session, so in that case, I am going to do that after every 1 minute. So in order to take that output, we are using the buzzer. So we need to initialize the buzzer as well. So we'll define a variable called buzzer, and then we'll define that with the classes. This is a PWM, and then it should be pin 25. Pin 25, and as we are taking output from this pin, we need to define it as a output. And then we need to make the buzzer turn off at the beginning. So to do that, we'll make the duty of the buzzer to 1. We can keep it 0, but without doing 0, we'll keep it like 1. Buzzer duty is 1. Here what we are doing is we are keeping our buzzer turn off at the beginning. So after initializing the buzzer, then we have to create a function to display the time. That means whatever the time updating according to the local time or real time, we need to display it on the OLED display. So to do that, we need to define a function. So this is how we are going to define it. So display time is the function name, and the thing it is referring to is the time str. Later we will define what is this time str, and then inside that function what we do, first we'll clear the display. That is why we inserted 0 here, and then we'll display the text that is coming under this time str at the position of 20 to 25, and then we'll show it. As we are defining a function, def should be there, and then the name of the function, we'll call it as display time. So what we need to display time is time underscore str, and then within the function, we need to put, and then within the function, first we'll clear the display, and then we'll show the empty display. So that is why we show it. And then again we need to display, what we need to display is in str at the position of 20 and 25, and we'll show it again. So here it should be OLED.text. Right, so this is the function to display time. So after defining the display time function, then let's define a function to activate the buzzer. Now in the beginning, we make it to turn off. Now we need to activate it. So we are making a function called playTone. In that playTone function, we require two parameters. That means the frequency and the duration. And then we are setting buzzer frequency to whatever the frequency we are setting, and the buzzer duty to 512, and the duration, that is turning on time, will be the duration we are setting. That is why we make sleep as duration. And after that given time, we need to turn off the buzzer again. So we'll make the duty to 1. We'll define another function, def playTone. So you can use any name to these functions. You don't need to use the same names. You can use any name, as it is easy for us to define the function name related to the function. Then it is easy for us to understand what is doing through this function. So to do this function, we need the frequency and also the duration. These two parameters should be there to call this function, right? And then we'll keep the buzzer dot frequency FREQ as the frequency we are giving, and then buzzer dot duty will turn on the buzzer, so we'll make it to 512, and then we'll keep the buzzer on for the time of duration time, and then we'll again turn off the buzzer, so we'll make the buzzer dot duty to 1 again, right? Okay, that is the function to turn or activate the buzzer. After creating the function to activate the buzzer, then we need to define a main function which comes with that time str thing. So we'll define the main function, and the main function is going within a while through because we need to do it repeatedly. And here we are defining a variable called current time, and that current time is the local time or the whatever the real time at the moment, and then hour, minute, second, three parameters are there. Those three parameters get the current time value 3, current time value 4, and current time value 5. Right? These 3, 4, 5 taken from this local time thing. You don't need to worry about that. And here we have that time str thing that we used in our display time function. So time str means this one. That is, time str means the format of the function, that hour, minute, second formats. And then we call it to display time as time str. Here, this is the function we defined earlier, and we are calling it here. And as I told you, after every minute, we are going to turn on the buzzer. No? So that playTone function is called here if seconds become 0. That means when 1 minute goes, seconds become 0. No? After 60 seconds, 1 minute is done. When the number of minutes increasing, when the new minute starts, the second value becomes 0 and goes on. So at the case of when the second becomes 0, we activating or we are calling the function we defined as playTone with the frequency of 2000 and with the duration of 0.5. And as we need to do this same process in after each and every 1 second, here we are giving a delay of or a sleeping time of 1 second. And then after defining this main function, within the main function, we call that display time function and the playTone function we defined earlier. And after calling this one, at the end, we are calling the main function like this. to run the whole program. So now let's define this main function. Def main, open and curly brackets, double dot, and within that we need a while through, double dot. So there should be an I here. And under the while through, we have to define rest of the things. So under the while through, we define the current time one. Like this. Current time, it is taken from the local time class from the library, from the time library. And then rest of the things goes like this. Now, what we need to do? Now we need to call this main function. Like this. So now we are done with the program for the clock chime. Now what we need to do is we need to run this program. So how you can run is just click on this run button here. When you run this, if you now if you look at your Magicbit display, it is like blinking, it is shiver, right? So I have done a mistake. I haven't added a sleeping of 1 second after this if condition to update this in after 1 second. So because of that issue, your Magicbit display will shiver. So let me add the sleep of 1 second here. After that, if you run this, I will stop for a moment. And after that, if I run this, now you could see the time is updating 1 by 1 seconds. If you look at here, now if you look at the display, here the time seconds is updating. When the second becomes 60 or 59, instead of become 60, at that 60 value, a buzzer tone will come and then it start from 1 at the same time. This minute also getting increasing. Then the minute value come to 60, then the number of hours will increase. Look at here now, the number of hours is something like this because it is a evening time. Now look at here, when the time is become 00, you will hear the buzzer tone. Actually, the second time becomes 00, right? So after each and every 1 minute, you can hear the buzzer sound because we call the function to happen after every 1 minute. If you need to do it after 1 hour, you can change that. Yes. So we did our clock chime activity, and also we are done with this 7 days Python with Magicbit program as well. So if you are looking to learn or if you are looking to work with Magicbit furthermore, you can visit Magicbit website for more details. And through the Magicbit website, you can contact Magicbit people regarding the issues you are facing, or if you need to upgrade your products, or if you need to get help from them, you can contact them via the Magicbit website as well. And also you can follow other videos that included in the Magicbit YouTube channel. If you haven't subscribed the YouTube channel yet, please subscribe and click on the bell icon. Then you will receive more videos and notifications once we share many other videos regarding the Magicbit activities. So thank you so much everyone for joining with us. So wish you all the very best. Let's innovate and change the world in future.